In this class, I'll talk about uh, the virtual functions. In our last class, we found how virtual functions can be useful to ensure dynamic binding, which is essential when we implement hierarchy of classes using the easy relationship. In this particular class, we'll see more on virtual functions and not only normal functions, but we'll also see that how virtual destructors are useful, and in sometimes and there are cases where if you don't use virtual destructors, the outcome may be dangerous. I mean, if you use pointers in the classes and all. So this should be in this class I'll be talking about this much, and the next class will be focusing on the implementation of virtual functions, how the virtual functions are implemented internally using vtables and vpointers, virtual tables and virtual pointers, so that this dynamic binding is enabled. Okay, so let me share the slides. Polymorphic types and virtual destructors. So just to summarize the last class of whatever we have learned, the dynamic binding that we discussed mostly, I mean, in our last class we talked about both static and dynamic binding cases, and we found that dynamic binding can be required when we use function pointers, and at the same time if you use reference to functions also, we may require dynamic binding at times. And to ensure that the binding of a function body with its whenever it is called, to make it dynamic, we have to label that particular function as virtual in the corresponding class where it is defined. Okay, so what we found, the virtual function is an inheritable and overridable function or method which facilitates dynamic dispatch, and the process of selecting which polymorphic operation to call, it will be at runtime if we do so. And this is making functions virtual. This will enable runtime polymorphism, one of the very important concept of object-oriented programming. And essentially, virtual function defines a target function to be executed, but the target might not be known in the compile time. So these are the cases when we do so. Because we found that due to upcasting, the base pointer can point to both the base object or a derived object. And if it points to a derived object, we would expect then whenever a function is called, a common function that is named in both, that has been overridden in both base and the derived, it should be called in the derived function, derived version of it. So this should be done in compile time if we do so. The other 2 points is like if we override the function name, it will be overriding the, it will be hiding the base function body. And another important fact is if we have got three classes, this is a base class, so this is the derived class, and that is another class derived from this. So if we have got multi-level hierarchy, so if we have defined one particular function as virtual in the topmost base class, so the same function, if we overwrite in the next class, which is derived from the topmost base class, then even though we don't label it as virtual, it will be inheriting the virtual nature of the function. And the next to next class, which is derived from the intermediate base class, the function in the bottom class also will be treated as virtual. So the point is, if we label some function as virtual in the top base class, it will remain virtual in the down the hierarchy, even though we have not specified explicitly. Now we talk about polymorphic hierarchy. Now in a hierarchy of such processes, such classes which implements is a relationship, if any of the class, I mean specifically the base class, have declared at least one function as virtual, then the whole hierarchy, because the virtual keyword or the virtual nature of the function inherits down to the bottommost class. So the entire hierarchy becomes uh, you know capable of having a virtual function, and thereby it become a polymorphic hierarchy. Now why it is called polymorphic, and thereby if we create any object of that type of hierarchy, if we create a pointer to that pointer of a class of that belonging to that hierarchy, so those also will be polymorphic. So having at least one class as virtual in a particular class hierarchy will make the entire hierarchy polymorphic, and thereby all the objects, any objects belonging to that hierarchy instantiated from that hierarchy will also be polymorphic. And polymorphism in this case, which literally actually means a particular thing with multiple, which can take multiple forms. This is polymorphic because as we found that the base pointer, depending on if it is invoking through the base pointer, if we invoke a virtual function, then we'll have the flexibility, or it will actually have the option to choose either a base class, a base version, or a derived version, whatever. So because of this capability that even though you use a base pointer, but it, depending on the context to whatever it points to, it can trigger a suitable function body. Because of this nature, uh, this this entire hierarchy becomes polymorphic. Okay, so that is what we found. So in next we'll talk about one example where we'll see a multi-level hierarchy before we get into the actual virtual destructor and the use of it. So this is an example of a virtual function which involves multi-level hierarchy, and we have inherited in instrument class. It's a more general class. It's a base class. Let us think of. We have inherited a guitar class from that. So guitar is an instrument, and electric guitar, or there is sometimes there are acoustic guitars. So these are different types of guitars. So we can say electric guitar is a type of guitar, and in turn guitar is a type of instrument. So we have got this multi-level hierarchy. And if you look into the just a minute. Class definition. So this is the base class. This is the guitar class derived from instrument, and this is the electric guitar class, which is derived from the intermediate base, that is guitar. So that is how it is defined. And each of the three classes, they have overridden, or they have defined, the base class has defined all the three methods. These are dummy methods, but this is useful. This is tuning to ear. So ear tuning is a method that I have mentioned. This is playing a particular track, play, and this is display notes. So no matter what the actual function does, so you have three functions: tune ear, the play, as well as display notes. And we have, so here we show it like this: tune ear, play, and display notes. And display is in blue because we have tagged it as virtual, so that's why it is in blue. And within the methods, we have mentioned, we have given a small comment because we are not interested in the body or how exactly this tuner should work, but it just says that which version or which class this particular method belongs to, so that we can see the display. So instrument, display, instrument, tuner, and all this. In the guitar class, as you can see, even though we don't write anything, so all these three classes, three functions would have been inherited in the guitar class. But now I have decided to override all of them. So this tune ear, play, and display notes. The thing is, I have just changed the prompt or the message that it displays with guitar to identify that these are parts of the guitar class. At the same time, now in terms of the virtual nature of the functions, as you can see, we have explicitly mentioned display notes as virtual, but we have not mentioned anything about tune ear and play track, and play. But as you can see, play was declared as virtual in the base class. So when it gets inherited, even though we override the body of it, but the nature, the virtual nature is also inherited. So that's the point. And display nodes, it was not virtual in the base class, but now we have declared it as virtual. Okay. So in the guitar class, we have got two virtual classes. So the virtual classes I have denoted in blue. And finally, in the electric guitar class, we have got again the three methods or three functions overridden. And here, as you can see, we have not tagged any of these functions as virtual, but by virtue of the inheritance, display it was virtual in the previous in its immediate base. Now it will be treated as virtual. So now here also it will be virtual. It will remain the same. So the virtual corresponding to display, we have tagged the play in the base as virtual, but the virtual keyword gets inherited. The nature gets inherited in this immediate derived class and also this derived class also. So that is one thing to be noted. Here the display nodes has been tagged as virtual in the guitar class, which gets also passed on, and this display nodes in this electric guitar also will be considered to be virtual. Here the virtual nature is inherited. Okay. So to summarize, instrument will have one virtual function, the guitar will have two virtual functions, and also the electric guitar will have two virtual. And throughout, the tuner is non-virtual. Okay, so here we create two pointers of two base classes. So here this is the topmost, it's a root base class, and this is the intermediate base class. So both are base classes. So we have created a pointer of type instrument and a pointer to the guitar class. So this is what is PG and PI. And all that we are doing is creating an object of electric guitar type. So the final derived object, or the most derived class is electric guitar. We are creating an object of the electric guitar type, and we are assigning the address of this object to this guitar pointer and also to this instrument pointer. Okay, so here when I see, I mean, this is a PI. PI is an instrument pointer. If I write this is PI, so what its type? It's instrument pointer. So it's instrument. So instrument pointer. So we are talking about this part. So PI, what it points to? It points to PG, and PG is actually pointing to electric guitar object. So this PI is actually pointing to an electric guitar object. So like this. Okay. So through that PI, if I call tuner, play, and display nodes, so let us see that which version of the method or function which will be actually invoked. Now the thing is, the rules are simple enough. The first thing is PI invokes, say, tuner. So first question we should ask is tuner virtual or non-virtual? Where? In this level, I mean in this particular level. So I would. So what is this? This is instrument class level. Instrument class level. What is this? Play is virtual, but other two are non-virtual. So here tuner is non-virtual. So if it is non-virtual, so we now would like to decide that whether this invocation will trigger a static binding or dynamic binding. Now, because tuner is static in this instrument class level, so there is no question about it, and it will simply trigger static binding. And static binding means, in that case, the method corresponding to the class to which the pointer belongs to. The pointer belongs to instrument type, so it will basically simply trigger this tuner in the instrument. So this is static binding, and it will be triggering this instrument tuner. Now next comes PI play. So when it comes to the play, now the compiler in the runtime will see that when during compilation it will find that the tuner display. Some interruptions in the screen. Anyway, so this PI play. So the PI play. So it was PI. Py was pointing to this integer object. So pi play. So pi play is a virtual function. So once it knows that play is a virtual function, it will simply, the compiler will not bind it during the compilation time, it will defer it for dynamic binding. So dynamic binding, why? Because play is a virtual function in that level, in the class to which pi belongs to. Okay. So now if it is virtual, say dynamic binding, so which copy it will trigger? It will definitely trigger the, so now comes that which body it will trigger. So will it trigger the copy to which pi belongs to, or the copy of the class which pi points to? So because it is virtual binding, so it will trigger display. That is, the rule says, in that case it will see that what type pi points to, not what type pi is. So then this play is triggered, and that's why electric guitar play is triggered. So this will correspond to this one. Now when pi triggers display notes, again the question comes, is display note a virtual function? No, it's not a virtual function, it is in black in this level. So in that case it will be static binding, and static binding means it will simply trigger the copy to which the type, to the corresponding to the type of the class pi belongs to. So it will be instrument display note. So this is like this. Now we have got this PG. So PG is what? PG is a type of guitar type pointer. It's also a base pointer. So PG is also a base pointer because corresponding to with respect to the object that we have created. So we have created what? Electric guitar type object. So object of this type, and PG actually is pointing to the object of type electric guitar. So in this level you can see, if PG calls ear tune, so ear tune is here also it is non-virtual. So it is non-virtual, simply static binding, and in that case it will simply trigger again the same things getting repeated. So the copy of the function corresponding to the class to which PG belongs to. So PG belongs to guitar type, so it's guitar type. That's why it calls guitar. Okay. So this is so corresponding to this statement, this will be a display. Now PG play. So PG play, what type of function play is? Play in this level, as you can see, it is a virtual function. If it is a virtual function, it will ensure dynamic binding. And which copy to call? Dynamic binding means if you see that what, it's not the type of what PG is, but the type what PG points to. PG points to electric guitar type. So the electric guitar, if it has got overridden copy of play, it will simply trigger that. It's dynamic binding and it triggers electric guitar. Okay, so this is corresponding to this. And finally, PG display notes. PG display notes, is it virtual? Yes, it is virtual. So if it is virtual, then again PG will trigger the corresponding method, the method corresponding to the type of the class that it is pointing to, the object class type that is pointing. It's pointing to electric guitar, so again this will be invoked. So electric guitar display notes will be invoked. Okay, so through this exercise we have found how in a multi-level is a class hierarchy, inheritance hierarchy, we have a base class base pointer, both corresponding to the topmost and the intermediate base, is pointing to a derived class object, and by virtue of the virtual keyword getting inherited in the descendants, in its descendant in the derived classes, how if we make the calls to the functions, how they will trigger their copies of different classes. Okay, so that is what it shows. Now we come to the destructors, as to know that why destructors are essential and why it is required. So we found that in a class hierarchy, if overridden is there, virtual functions are essential. But till now we have not been able to appreciate or find out whether constructors, destructors also need to be virtual. That's the point. Now When we come to the construction part, we find that construction, it is like when you create a derived class object, it in turn should create or call the base constructor if requires passing parameters and all. That is how it is done. So this part we know. But when it comes to the destruction, there might be some unwanted, unexpected outcomes if destructors are not declared virtual. Let us see what can be the case. So we have got here a very simple class without any methods, additional methods other than constructor and destructors. So this is the base class, and this is the derived class which has been derived from the base class D. So this B, the base class, D has been derived from B, and both are having just a constructor and a destructor, as well as a display method which has been labeled as virtual. So display is a function which has been labeled as virtual here, and it is displaying, and it has got one data member B1, and here it has got one data member, say asterisk P, and the B colon B1, it has been inherited from the base class. So that is what it is. And here if we look into the constructor of B, we find that whatever you pass during construction, that will be initialized. B1 will be initialized to that. It will display the constructor name. Destructor also is trivial. It will display the destructor name, nothing meaningful here. The display, it will try to display the value of B1 that it has got. So this is pretty simple, but this is the virtual function, that is the virtual function, and by virtue of that, this display also becomes virtual. Now if we come to D, the D class, we have got one constructor, and it I've decided to pass on two arguments, one for constructing or initializing its own members, and another that will go on and initialize this B1. So using this X, I'm calling the constructor of the base with Bx, which will be initializing in turn B1, and this P new int. So this what it means, this is same as P assign the value of the new object's address, new int y. Okay. So this is same as this. So you could have written here inside this constructor also, but I have preferred to write in a more compact form. That is what it is. Okay. So now this is the display function, which is inheriting the virtual keyword here, and the display function, it accepts. So it should be void because there's no. So this is a mistake. So it should be void, and within this, it first calls the corresponding display function of space. So that's why B colon display it calls, and then it simply displays the contents of whatever P points to, because P is integer pointer, and whatever address it has been allocated here during construction, and the contents of that will be, so asterisk P will be displayed. That's it. And B display will display the value of B1. That is the other two functions that we have defined, and within this main, I am just creating a base pointer base, which is of type B, and dynamically allocating a derived object D. So it takes two arguments, so D2, 4. This new object through this new I have created. So this derived object D will be created in the heap segment. So this is the derived object D. So this is the D type object that has been created. Okay. So object D in the heap. Now what we'll have, it will have the inherited part of B. Sorry. So this is B, and when it gets constructed, so B of X, so whatever value we have passed 2, so that will be initialized to this B1. So B1 gets 2 first, and then it calls P new int. So it will allocate another space for another integer variable, and will assign there 4. Okay, so this Y is 4. So this will trigger this one, and this 4, and whatever it is, this new location is, it will be, its address will be stored in P. Okay, so this is a construction of the object of type D, and once it is done, then the address of that object is assigned to the pointer base, so which is a pointer of type B. So it's a B type pointer, base type pointer. It will be in the stack segment. Okay, so now once this is done, we call PTR base arrow display. So now to figure out which, so there are two displays, which display will be actually triggered. Again, the same thing, display is a virtual function both in here and here. So because it's a virtual function, the pointer will look into the type of the object or the class type, the object's class type, and it will trigger that. So now it finds that a pointer is pointing to a D type object, so it will trigger the display corresponding to the derived class D. So that's why so that will come later. So here we find that when it constructs the object, it first calls B. So this B is called B constructor, and then it constructs this part and displays it. So that's why B and D. Okay. So in the next slide, we'll come to this PTR based display. So now we see that so when it displays both 2 and 4. So 2 gets displayed through this, because when it calls display, as I mentioned, because display is a virtual function and PTR base is pointing to a derived class object, it will actually invoke the derived copy of display, which first will display this base display, that is 2 is displayed, and then followed by whatever P is pointing to this 4. So this is what is done. Okay, so this 4 corresponds to this one. So now once this is done, then we call delete pointer base. Now that is interesting. So if we call delete pointer base, so we expect that whatever this pointer is pointing to, that space will be deleted. Now the thing is, but we know that before deletion, we have talked about it in details while talking about overloading new delete operator and all this. So we know that whenever this is called, the default delete operator, what it does, it invokes in turn the corresponding destructor of the object. Okay, now this PTR is a base pointer and which is pointing to a derived object. So the thing is, now what it will see that delete PTR base will need to trigger our destructor. Now which destructor? Because now the pointer is of type base and the object it's pointing to is type derived, so it has got 2 choices. But because it finds that if you look first into the pointer type, pointer is of base type. Now it finds that the destructor, the corresponding to the base class, is non-virtual. So because it is non-virtual, so it will be treated like as if you are trying to invoke the destructor method, destructor function, but the destructor function is treated as virtual in the base class to which pointer base belongs to. So it will simply perform a kind of static binding, or it will trigger the base object's destructor, base class's destructor. So what eventually will be done is, is to call this one. So whenever we call this one, what we see? So it does basically nothing. So at the end of this destructor, what you find is this portion. So this portion where it was B1, so it basically delete that part. So that part gets deleted. However, this part, which is a part corresponding to the derived portion, that is P or whatever P points to, everything remains intact. So the thing is, if we do so, the entire, so in terms of the entire derived object that is there, this delete operation or the destruction of the object when we call delete PTR base will be actually destructing part of it. That is, the base portion gets deleted, but the derived portion remains intact. So this is what is observed and is better known as object slicing. So the object is basically sliced, the derived object. You are trying to destroy the derived object through some base pointer. As an effect of it, it gets sliced off. So the derived portion remains and the base portion goes off. And as a result, as you can see, this remains as garbage and nobody will take care of it. Okay, so in C++, there is no inherent garbage collection mechanism, and such cases should be avoided. So how to avoid this? So again, the simple cause is, so what we should have done, or what we should have expected here, that whenever we call delete pointer base, so it should have called the derived classes destructor. So to make it happen, because you are calling it to the base pointer, to make it happen, you have to tag this as virtual. So the base destructor, if you tag it as virtual, this will happen. Okay. So let us see that how it works. So here it is. See, we have made it as tagged as virtual, and defining the base destructor virtual makes it a polymorphic type. So the whole hierarchy where B is a type of D, the whole hierarchy of classes, that these two classes becomes a polymorphic hierarchy, polymorphic type, which in turn makes the destructors of all the derived classes into the hierarchy also virtual, and thereby it can avoid object slicing. How? Now you see, now when this is called, so because it will be implicit destructor call, but the destructor of that base class is virtual, so it will intelligently go for dynamic binding, and thereby this will trigger now the call to this one. Okay, so this is because this will be of dynamic, this will ensure dynamic binding. Okay, so now once this is done, what you see is the thing that we expected. So first we will display the prompt that it is actually executing the destructor of the derived class, and then we call delete p, which will in turn deallocate the space pointed by p. That because we have allocated the space in the constructor, and it should be properly deallocated. So this happens, and then after it is done, then automatically so after this, then this is called. Okay, because this will be followed by the base destructor call, because this is normally done. If it is a normal object destruction, derived object, you would have called the derived destructor and then followed by the base destructor. So here the same thing will happen if you simply if you make the base destructor virtual. So what is the advantage of doing that? It enables dynamic binding of the destructor, ensuring invocation of destructors corresponding to the suitable class type that the base pointer points to. Now to see that, now if we create, instead of a derived class, if we create a base class type and ptr base assign points to it, so we display ptr base display. So in that case, although display is, so now ptr is of type B, ptr is pointing to object also of type B. So then if I call ptr base, now this will ensure, even though both are of same types, it will ensure dynamic binding. Okay, so it will be dynamic binding, but the dynamic binding will simply trigger this copy. Okay, so what we have missed here is the value of 5. So we could have displayed 5 here. So the value of 5 will be displayed here in between. Okay, so here the value of 5 will be there, and after that when we call delete ptr base, so delete ptr base, now ptr both are of the same type, so it will simply trigger this destructor call and thereby getting this prompt. Okay, so this is one case where we find that why the solution to that object slicing, we can avoid object slicing of objects in case we have gone for upcasting and then we at some point of time we are deleting the objects pointed by the base pointer. To avoid in such case the scenario of object slicing, we have just declare the base class destructor as virtual, that will in turn make all the remaining destructors down the hierarchy as also virtual. So just to summarize, a dynamic binding is possible only when the object reference or object pointer types, only when you use the reference or pointer types of the objects, and it is applicable only for virtual member functions. A virtual function is inheritable and overridable method which facilitates dynamic dispatch. A function which has been declared as virtual in the base class continues to be treated as virtual in all the classes down its hierarchy. A polymorphic hierarchy is a class hierarchy consisting of polymorphic type classes. And how to create polymorphic classes? If at least one of its member function is tagged as virtual, you can simply tag the destructor as virtual, and then that also makes the whole hierarchy as polymorphic. The polymorphism is a technique, so we have mentioned that. So how polymorphism is exhibited here, and finally we have talked about how the destructors must be declared as virtual in a base class to avoid object slicing. And the point that you note is, if the derived class has got something to do in the destructor, it's not a trivial destructor, it has got some space to deallocate or something else to be done. If it is doing something meaningful, that any of the derived destructors are need to do something meaningful, in that case the base class should declare its destructor as virtual. So the base practice is, when you are implementing the base class, you are not sure of how the derived classes will be defining the destructors or constructors. So the best practice is, whenever you have a class hierarchy, in that case, just better to tag the destructor as virtual to be safe, so that you know the derived classes, they have written something meaningful, it would have been taken care of in case their object pointers are object addresses are upcasted and you have did something. Okay, so the point is, better to it's must, or it is a good practice to declare a destructor of a class as virtual, because you even do not know whether you have been deriving objects classes out of your from your class. Okay, so in the next class, so this will be the end of this class. In the next class we'll be talking about what goes under the hood, or how these virtual functions are implemented internally, so that the base pointer is intelligent enough to find out which function body to actually execute or invoke base copy or derived. So how internally it is implemented, that we'll see. Okay, thank you.